Bismillahirrahmanirrahim. Dear students, welcome to the course of Artificial Intelligence. We are discussing lecture number 12, and the main topic of the lecture is expert systems. This is your teacher Tariq Aziz, lecturer at Institute of IT, Kohat University, HANGU-CAMPUS. So let's move on to the agenda. Okay, dear students, the first topic is that for which sort of domains we can develop expert systems. Now it says that when analyzing a particular domain, to see if an expert system may be useful, the system analyst should ask the following questions. Now, we have to focus on these questions if we want to know that should for the specific domain we can develop a expert system or not. So, if we can find answers to these questions, then we can develop an expert system for a particular domain, but if not, then we cannot develop a particular an expert system for a particular domain. So what's the first question which the system analyst should ask? The first question is that can we solve our problems by writing the conventional programs, by using the conventional languages? For example, if you can solve your problem using C++ or Java, which are conventional languages, then there is no need to develop an expert system. But if you cannot solve your problem by using conventional programming, then indeed you have to develop an expert system to solve your problem. Okay. Because expert system it well suited the ill structured problems. Now there are structured problems and there are ill structured problems. As a home assignment, search the internet for these two types of problems. Now it says here that expert systems are especially suited to ill structured problems. Okay. Now the second question is that the domain should be well bounded. If the domain is not well bounded, then we cannot develop an expert system. So, for example, the headache diagnosis system. This domain is not well bounded. We cannot develop an expert system for a headache diagnosis system. Let's say if you want to develop an expert system which will be capable of identifying the headache symptoms. Okay. Now we know that this domain is not well bounded because the reason for headache involve different areas of medicine. So that's why this domain is not well bounded. We cannot we cannot develop an expert system for such system. Why? Because it is not easy to limit diagnosis to one area. So to summarize, if the domain is well bounded, then we can develop an expert system for that. But if the domain is not well bounded, we cannot develop an expert system. Okay. Now, here it says, with respect to the second point, it says that in cases where the domain is too wide, building an expert system may not be a feasible option, as we discussed a couple of minutes before. Now, the third question is that you should concern the practical issues. And what are these practical issues? First of all, as I said, that to develop an expert system, we need a human expert. Why? Because we will gather the knowledge of the human expert, we will get the knowledge of the human expert. Also, we will try to understand that this human expert, how it perform reasoning. So we discussed these 2 points on the in the previous lecture. Now here, this point is very important, that is this human expert willing to cooperate? Because if this human expert is not willing to cooperate, then correspondingly, ultimately, we cannot develop an expert system. Okay, and The next question is that is the expert's knowledge especially uncertain and heuristic or not? Okay. And finally, if so, expert system may be useful. So these are the practical considerations which we have to consider. First of all, we need to know that whether the human expert will cooperate or not, and second thing is whether its knowledge is well established knowledge, we can say. Okay, if so, then we can develop an expert system. So the question is that for how we can or what are the appropriate domains for expert system. This question is based on these three questions. That first of all, you have to check that if you cannot solve your problem by using programming languages, then you have to choose the expert system. Second thing is that domain should be our domain must be well bounded, and third thing is that you have to consider these practical issues, whether the expert is cooperative or not, whether his knowledge is well established or not, etc., etc. So based on these questions, you can choose whether to develop expert system or not. Okay, now dear students, our final topic is the expert system structure. So what is the structure of the expert system? To understand this, you have to consider an analogy of a doctor which solve problem. So the expert has the following characteristics. Okay, and we already discussed this in the previous lecture. First of all, uh, focused area of expertise. The second thing is that the an expert will have a long term memory, which is known as LTM, and which is also known as an expert will have a specialized knowledge in certain domain. And then an expert will have the short term memory, which is known as STM. The current facts or the case facts are known as the short term memory. And then expert is capable of performing reasoning with the form with these to form new knowledge. So actually expert will use the specialized knowledge. Expert will use his specialized knowledge along with the current facts, and then he will perform. Okay, the question is how expert will perform this reasoning. Actually, expert will perform this reasoning process on these two options. Expert will use his specialized knowledge. Expert will take the current facts from the environment, and then he will perform the process of reasoning to solve the problem or to deduce new information. Now this is these all these points are with respect to an expert. Okay, so how the expert system will perform, or what's the structure of the expert system then? Okay, why we discussed the characteristics of the expert? Because the structure of the expert system resembles these points. Now look at the next slide here. With the help of table, let me try to explain the concept that this is our human expert and this is the expert system. Now human expert, it will have the focused area of expertise, while in expert system it is known as domain. Okay, then human expert, it will have the specialized knowledge of certain domain, which it will store in the long term memory. But in expert system, we represent this with domain knowledge, and expert system store this domain knowledge in knowledge base. Then the human expert, it takes the current states or facts from the environment, and then it store all these current facts or state in its short term memory. In case of expert system, we represent this with the inferred facts, and expert system will store these inferred facts in working memory. Then human expert, it perform the process of reasoning to solve the problem or to deduce new information, While in the case of expert system, there is an engine which is known as inference engine. Actually, this inference engine will perform the processing to deduce new information or to solve the problem. Finally, we will have solution here, and in this case we will have the conclusions here. Okay, so this is the basic structure of the expert system. Let me explain this structure of the expert system with the help of the diagram. So here we have the working memory, and in working memory, what we will have, this working memory can also be represented by the short term memory. The current facts which the expert system will gain from the environment, okay, are initial case facts, we can say initial case facts, we can say inferred facts. So all these facts, the expert system will save all these facts in its working memory. Now what will be in the knowledge base? In the knowledge base, the domain knowledge will be domain knowledge will reside here. Knowledge base will store the domain knowledge, and we will the analogy is long term memory. Okay, so the short term memory of the expert system, the working memory is also known as the short term memory of the expert system, while the domain knowledge or the knowledge base, it is also known the long term memory of the expert system. So inference engine is here in between working memory and knowledge base. Now what this inference engine will do, it will take inputs from here from working memory. In working memory we have the current facts of the environment, and then it will consult the knowledge base, and finally it will do its processing and then produce output to the user. Okay, so this is the basic structure of the expert system. Now dear students, I already explained all these terminologies, but let me explain here that what is knowledge base. Knowledge base is basically a part of an expert system that contains the domain knowledge. So all the problem facts, the rules, the concepts, the relationships, all these are included in the knowledge base. Dear students, let me explain this concept with the analogy of a doctor. Now a doctor for 4 years, or for 4 years he will do his bachelor's degree in a college, and then he will perform some house job. Okay, so all this knowledge is known as his knowledge base. 4 years in the college and then 1 or 2 years doing house job. So definitely he will get some knowledge. So all this knowledge is known as the knowledge base of a doctor. Okay. Now here it says that what is the main element of for an expert system, or what's the power of an expert system? It's the richness of knowledge. So if we have a rich knowledge, then expert system will perform well. Now here it says that therefore one of the prime roles of the expert system designer is to act as knowledge engineer. Okay, and what the knowledge engineer has to do? The knowledge engineer must acquire knowledge in an effective way, and then it should be able to encode this knowledge in knowledge base using the knowledge representation techniques which we studied in the previous lecture. Okay, now what's the working memory? Dear students, definitely the expert system will get some current facts from the environment, like for example, if we want a diagnosis system, then definitely this diagnosis system will ask some question from the user. So what this expert system is basically doing, taking the current facts from the user, and then it will store these current facts in the memory which is known as the working memory. Okay, so it's a part of the expert system that contains problem facts that are discovered during the session. So the diagnosis expert system, it will take a session with a patient, and then it will ask maybe it will ask a question from this patient, and then these current facts it will store in the working memory. Okay, so according to Durkin, what is a session? Session in working memory corresponds to one consultation, and during this consultation what the expert system will do, User will present some fact about the situation, and then the expert system will take all these facts from the user and store in its working memory. And then using these current facts and the knowledge stored in the knowledge base, the inference engine will perform its processing, and new information will be inferred, and then these new information will be added to the working memory after inferencing. Okay, so what's the inference engine then? It's like a processor in an expert system, and it will perform processing. So how it will perform its processing? It will match the facts contained in working memory with the domain knowledge contained in knowledge base, and then it will draw conclusions about the problem. So this is the working phenomenon of the inference engine. Now, dear students, if the knowledge of an expert system is represented in the if then else form, then the inference engine has the following strategy. So how this inference engine will work? It will match the given facts in working memory to the premise of the rules in the knowledge base. If match is found, then it will fire the conclusion to the rule. What it means? That it will add this conclusion to the working memory. And then it will perform this operation repeatedly until it found the desired conclusion. So let me explain this with the help of this program. Now here we have a knowledge base. In this knowledge base we have three rules. Rule number one says that if x is the father of y and x is the father of z, then y is the brother of z. So this is the first rule. What's the second rule? Second rule says that if x is the father of y, then x pay tuition fee for y. This is the second rule. Now, what about the third rule? It says that if x is the brother of y, then x likes y. Okay. Now, dear students, we already covered a lecture of prologue programming, and we practically saw some of the programs, and I already discussed all these rules, everything in detail. So I would recommend that you should revise your concept. Now look at the working memory here. Okay, so what the knowledge base will do? It will look at the, let me go to the previous slide. So the working criteria of inference engine will be, it will match the given facts in working memory to the premise of the rules. Now here, these are the facts in the working memory, and this is the premise of the rule. The if part is the premise of the rule, then part is the antecedent of the rule. We already discussed this. Okay, now dear students, so it will like it said that inference engine will match the given facts in working memory to the premise of the rules in the knowledge base. Now here, this is the fact in the working memory. So what inference engine will do? Take this fact and then match with this premise of the rule. Okay. So here it says if x is the father of y. Now what the prologue will do? It will substitute x or it will unify x with Mr. Tariq, and it will unify y with Mr. Ali, because here the predicate is father, also here the predicate is father. So now after unification, what we got, Mr. Tariq is the father of Ali. Now this after sorry, look at this. If match is found, what the inference engine will do? Add the conclusion to the working memory. Okay. So here, what the inference engine will do? Add this factor to the working memory, and then the second fact, father Mr. Tariq Ahmad again, and x is the father of y. So in this case, now the second premise is this one. Now prologue will unify this x with Mr. Tariq, as we know from the previous matching, and prologue will unify this variable z with Ahmad. Now Mr. Tariq is the father of Ahmad too. So Prolog will add this fact to the working memory too. Now rule 2 says that if X is the father of I or Y, then X will pay tuition fee for Y. So first of all, Prolog will look at the working memory. Okay, here Mr. Tariq is the father of Ali. So this match is found. Now the second part of the rule is that if X is the father of Y, now we found that Mr. Tariq is the father of Ali, match is found, then this X will pay tuition fee for Y. So Mr. Tariq will pay tuition fees for Ali. Now Prolog will add this fact to the working memory. And also here the second fact says that Mr. Tariq is also the father of Ahmad. So definitely Mr. Tariq will pay tuition fee for Ahmad too. So Prolog will add this fact to the working memory. Now the rule 3 says that if X is the brother of Y, okay, and here the then part, okay, then part, yeah, we missed this part, the then part, that if X is the father of Y and X is the father of Z, then Y is the brother of Z. So in this case, Mr. Tariq is the father of Ali, Mr. Tariq is the father of Ahmad too. We already looked at this. Then Y is Ali and Z is Ahmad. So Ali is the brother of Ahmad. Prolog will deduce this new information and will add into the working memory. So the second rule is with respect to tuition. Prolog will match found match, and then it will add the facts into the working memory. Sorry, the inference engine. Okay. Now, dear students, rule number 3 says that if X is the brother of Y, X likes Y. Okay. Now, in working memory, we have this fact that Ali is the brother of Ahmad. So, Ali like Ahmad. Okay. Again, the inference engine match the found. Now, correspondingly, it will add this fact to the working memory. So, this is the basic working phenomenon of the inference engine. Now, dear students, this was all about the expert system, and let me summarize the lecture today. Dear students, in lecture number 12, we basically looked at expert system. First of all, we defined that what is expert system. We said that it's an intelligent program, and then we looked at the comparison between the human expert and expert system. Finally, and then we checked some of the applications of expert system. That there are a lot of applications of expert system, and then we looked at the question that how we know that should we develop an expert system for particular domain or not. Finally, we looked at the structure of the expert system. Now, dear students, let me remind you again that expert system is one of the important topic of the artificial intelligence, and at this stage I hope that now you people understand that how and why it's an important topic of artificial intelligence. Enough for today's lecture, and with this third video lecture, our topic of expert system is finished now. Thank you so much.